So what we're going to be doing is we're going to be constructing a matrix or an array from a relation. This is a really important and very handy thing to be able to do because it allows us to mathematize relations and then allow us to do matrix algebra on them or to do any kind of like linear transformations. So let's start with some basic concepts. A relation generates a set of R made up of Cartesian coordinates. These are X and Y, and such that X implies Y is true. So we're basically going to get a conditional statement. We write X, R, Y. So X, Y belongs to R if and only if X, R, Y is true. So essentially R is going to be made up of a bunch of these Cartesian coordinates, and that relationship between X and Y indicates that X implies Y is a true statement. We use 0 to denote XRY is false, and we're going to use 1 to denote XRY is true. That's going to allow us to basically do some Boolean algebra kind of stuff. R is a subset of A cross B, and in the relation, X is a member of A, and then Y is a member of B. So this is kind of just reviewing just a little bit of the basics of how relations work and how our notation works as we go in and talk about matrices and arrays. So let's talk about the dimensions of a matrix. Every matrix is going to be made up of rows, which are horizontal, and columns, which are going to be vertical. If XY is chosen from AXB, the elements in A are the rows of the matrix, and the elements in B are the columns of the matrix. The number of rows is given by the cardinality of A, which we write as the absolute value of A, and that's the number of elements in A. So if there are 6 elements in A, the cardinality of A is 6, and that absolute value of A, that's going to end up being 6. Then the number of columns is given by the cardinality of B, which again is going to be written as the absolute value of B, and that's the number of elements in B. So let's suppose that we have this kind of example. We have the cardinality of A equals 4 and the cardinality of B equals 3. So the matrix M will be 4 by 3. And we'll actually write this as A, RB, we'll imagine. A is going to belong to A, B belongs to B. And then we'll generate our matrix. And so we'll have 1, 2, 3, 4 rows and 1, 2, 3 columns. And so what we're going to do is we're going to imagine that the columns head downward, the rows head across, and everywhere we have an intersection, we're either going to have a 0 or a 1. And we'll see that in a couple of examples in just a moment. So now let's take an example. Let's suppose that we have a group of students, A, which is going to be Tony, Andrea, Fira, and Jasmine, and a set of 2 assignments, B, which is going to be assignment 1 and assignment 2. Our relation is going to be defined as XRY if and only if X turned in Y. So if an individual turned in the assignment, then we're going to assign them a 1, and if they didn't turn the assignment, we're going to assign them a 0. So now we notice that A has 1, 2, 3, 4 elements in it. So we're going to have 4 rows, and B has 2 elements in it, so it's going to be 4 by 2. Okay, and that makes sense as it's the individual turned in the assignment. Now we're going to generate the matrix. And so what we'll do is we'll order this in terms of how they're listed inside of A. Now what you'll need if you have an array or a matrix and all you're given is the array or matrix, you need some kind of key to be able to tell you what each one of the rows and the columns represent. But for our purposes, that we're setting this up this way. So we'll have Tony, we'll have him be first, we'll have Andrea, we'll have Firo, and we'll have Jasmine. And then we'll have assignment 1 and we'll have assignment 2. Now, we'll say that Tony did not turn in assignment 1, but he did turn in assignment 2. Andrea turned in both assignments. Firo did not turn in either assignment, and Jasmine turned in both assignments. Now notice we can read the matrix to see who turned in which assignment. And then we can generate our set R as, say for example, I'll let T be Tony, A be Andrea, F be Fira, and J be Jasmine. So we'll have T turned in 2, A turned in 1, A 2, F didn't turn in anything, so we won't have any elements in R for her. And then we have J1 and J2. and that's our set R, based upon this particular matrix or array. That kind of gives us kind of a relationship between that set, the ordered pairs, the Cartesian pairs, and how we write the array. Let's take a look at another example. Let's suppose that we have a set A, which is equal to 1, 2, 3, 4, 5, and 6, and that R is a subset of A cross A. And our relation ARB, if and only if A times B is even. Now in this case, our relation is defined on a domain A, that is a single set. And so consequently, we'll have the same number of rows and the same number of columns. Since there are 6 elements in A, our matrix, call it M, is going to be 6 by 6. And that'll be the elements of M. Now what we'll do is we'll generate this matrix. We'll have 1, 2, 3, 4, 5, 6 along the column rows, and 1, 2, 3, 4, 5, 6 along the columns. And now, make this a little more even. What we'll do is anytime we multiply a row by a column, if that value is even, we're going to put in a 1. If it's odd, we're going to put in a 0. 1 times 1 is 1, so that's odd, so we're going to give it a 0. 1 times 2 is even, so we're going to give that a 1. 1 times 3 is odd. 1 times 4, even. 1 times 5, odd. 1 times 6, even. Now, since 2 is even, anything that I multiply 2 by is going to be even, so that entire row is going to get a 1 because 2 times any one of those values is going to be even. When we multiply by 3, we're going to have the same thing that we had with 1. 3 times an odd number will be odd, but 3 times an even number will be even. So we end up with 0, 1, 0, 1, 0, 1. Then 4 is going to be the same as 2 because anything times 4 is always even. 5 will be the same as 3. And 6 will be the same as 2 and 4. So there's our matrix representation of this particular relation where A times B ends up being even. So let's review a couple of key points. 1, R is going to be a subset of A cross B, and ARB is the relation R. If the cardinality of A is M and the cardinality of B is N, then the matrix is going to have the dimensions M cross N, with M being the rows and N being the columns. If ARB is true, then we're going to put a 1 in the space on the matrix corresponding to the intersection of A's row and B's column. If it's false, we use a 0. I hope this was helpful. I really enjoyed making it for you, and good luck working on relations. This is Dr. George Sweeney, and I want to thank you for watching my video. If you found it helpful and you liked it, go ahead and click the thumbs up. If you want more of these videos and you want to get my updates, please click subscribe. If you have any questions or you just want to say how much you really enjoyed the video, go ahead and leave some comments. I do read and respond to the comments.